Thanks to the organization committee for giving me this fancy place of being speaker number one and being the only speaker talking about electrothermal processing. And you have seen my light difficulties here in getting the fire lit. So I would say the conventional combustion technology colleagues are more advantageous here for lighting this fire. But at the end of the day, also electrothermal process technology was able to do something. Yeah, my pleasure will be here for, you excuse me, this is the tribute of not dying young, so I will take this technical feature in order to facilitate a little bit my presentation here. Yeah, I want to talk with you about induction reheating for the reducing of CO2 footprint in integrated Minimills. It's a long sentence, and I was trying to figure out what I could leave out of this long sentence, and there's really nothing which should be left out, because it is something which is a little bit special. It is the use of induction heating in a mini-mill concept, which we do together with our sister companies within the SMS group, and it is something which really can help customers not only from an environmental aspect, but also from hard facts in the economy. And my presentation is going to cover, the following points. First of all, I would be giving you a definition of this CMT technology. Then we will have a little bit of basics of induction heating, but don't worry, it will not be a lecture on physics. I will not torture you on that. I will present the key benefits of this CMT mini-mill concept when induction technology is integrated, and we talk both about the economical hard facts as well as about ecological production aspects. And theory is one thing, but as people coming from industry, you are probably more interested in having some hard facts and some hard evidence about what I tell you here. And I have the pleasure and the honor to present to you today some real data from our reference customer, Tung Ho Steel in Taiwan, which give us the permission to present that also in this frame here today. Well then, finally, we summarize, and I'm looking forward to a discussion with you about the subject. CMT, a definition, the basic idea of a mini-mill, of course, as you know, is the production and the processing of steel for long products in an integrated factory. And in the case of this continuous mill technology, this is CMT, continuous mill technology, the hot billets are coming directly from the caster and are fed through an induction reheating system directly into the rolling mill. So there is no storage in between. It goes from the caster through the induction reheating line directly into the rolling mill. And then, of course, we have fluctuations in temperature, which is a normal detail in such a process, and the induction system needs to be able to detect the incoming temperature, and the system needs to be able to compensate and equalize the temperature differences which are detected. And finally, what we want to have is an optimum rolling temperature, which is the ultimate customer demand. You see a layout here of a typical, let's say, a typical layout of such a CMT concept. And what you can see in the middle, very small, is the induction reheating system. And when we put the magnifying glass on it, you can see it a little bit better, but it's still a small fraction of the entire layout. But what we can show to you later is it has a substantial influence on the overall efficiency. Yeah, now we talk about the basics of induction heating. I need to torture you a little bit with answers and questions. Who has never heard about induction heating in the steel industry? Hands up. Okay, one honest answer. Who thinks he is a real expert of induction heating in the steel technology and steel industry? That's exactly what I thought. So we are somewhere in the middle between absolute beginners and super expert. That's very good. And this was exactly what I was expecting, because this is now the basis for my next slide. So induction heating, it doesn't matter if you use it in your private kitchen household or if you use it for melting steel, the principle is always the same. What we need is a primary current. In this case, it's going through our copper coil. And this current is inducing that gives the name, is inducing an electromagnetic field. This electromagnetic field is going through your metallic body, and by that another current is generated, and this current, we call it, as electricians, we call it eddy current, and this is able to heat up the workpiece from within. And this is maybe something that you can just take home with you. This heating concept is not bringing heat from the outside to any workpiece, it's generating heat in the workpiece itself, and by that there is a certain advantage in terms of heating speed. Okay, summarizing again, so we have the primary current, which is going through the inducing coil, then we have the electromagnetic flux, and finally the eddy current, which is responsible for the heating itself. Okay, now since we know how the principle of induction heating is working, what are the typical fields of application? When do we apply that? In industry, I'm not only concentrating here today on industrial use. I'm not talking about sensors, I'm not talking about kitchen appliances, so it's just the industrial use. Well, typically we have the possibilities of very high power densities and also high heating rates using induction heating with very high thermal and electrical efficiencies, and we have a very nice process control because we have already electrical data. We don't have to convert any kind of physical data into electrical measurement data. So it is oops, I was too fast. Excuse me for that. We have this very nice process control. And typical application areas are heating application in forming mills or forging shops, so where you have material, long products, billets, you name it, and you want to form them, you want to roll them, and you need a certain process temperature. You can heat up by induction. Also heat treatment like hardening or annealing, very common in the automotive industry. The picture you see down there in the lower left-hand side is a cut through the hardening process of an automotive crankshaft. So this is a typical state-of-the-art technology today. And you can see also in that little picture that we are only heating the outer part of the crankshaft. So we are not heating through and through, and this is certainly one of the advantages of induction, that by the right choice of the operating frequency, you can determine actively how deep you really want to heat the workpiece, if you want to stay more shallow on the surface or if you want to have a real through heating. In the case of our rolling mill here, of course, we needed to have a very thorough heating through and through. And last example here is a joining process, can be done by either welding or also by soldering, where you just heat the edges by the means of induction and the rest stays cool. Oh, hopefully cold. Okay, now on the next page, I put together something which definitively was not brought together only by Elotherm. I don't want to shine too glory when the work has been done by other colleagues as well. So this is a joint work of SMS Concast, Mayer and Elotherm together, where we gave you an overview of the typical mini-mill layouts. It all depends on the annual production capacity. And we have here 3 clusters. Something between 100 and 350 would be the first category. 1,000 tons per year, I should be correct. Then the second category would be something between 350 and 700, and then the bigger portion, something between 500 and 1 million tons per year of production. And depending on that production size, on that annual capacity, the rest of the components of this mini-mill is determined. This is, of course, true for the number of casting strands, and it is also true for the number of induction heating modules or units. And you will have all this information definitively in your handout, so we don't have to go through this spreadsheet line by line. When we take these 3 categories, I would say small size, medium size, and big size of annual production capacity, you can see another comparison between a mini-mill concept with the included induction system and a conventional mini-mill concept with a combustion furnace. And what we took here together is some specific energy consumption, and It doesn't matter if you have a small size, a medium size, or a larger size. In any case, you can have a substantial reduction of the energy you use for the annual production. So, and I don't want to be misunderstood, although I would be happy to sell induction heating lines to everybody in the world, but of course there are limitations to this concept. What we pointed out, or what we want to point out today, is for that kind of production range, the induction heating can be a viable solution, but we always have to have a closer look into the details in your existing concept or in an existing project, whatever you might have. But in this case here, looking at those numbers, you can see that there is a factor 7, more or less, which can be determined to be the energy saving factor when we use induction heating instead of combustion. And when we have a look into what can mean this information in terms of energy cost savings, well, we put again our 3 categories, small, medium, and large, and we took now the numbers of the energy costs in Germany. Of course, your numbers here in India, they are certainly different, and I will show that to you in one of the following slides. It always has to be taken into consideration what are the existing energy prices in your specific region where you think about installing a mini-mill. But the example calculation here is okay when we do that with the German prices. So we have 6 euro cents per kilowatt hour for electricity in our case here, and 5 euro cents for natural gas per kilowatt hour. And we determined the rolling temperature at 1000 degrees centigrade, and that brings us into energy cost savings of 3.5 euros per ton of the final product. But that is not the only effect. We have another effect, which is a production increase, because with the literally no scale formation, don't take it precise, it is always a little bit of scale formation, but substantially less compared to the combustion furnace. So that's why I said here virtually no scale formation. And we have here a number which we say 0.6% increase of production just by the reduction of scale formation. So which means there is less scale, there is a higher input and higher output of your production. And if you convert that again with the numbers which are true for the German structural steel market, and we talk about 450 euros per ton, the numbers come from 2013, so they are not that old. We have a yield advantage of also almost 3 euros per ton. And depending on the energy prices, you can really add these numbers, and this gives some quite interesting results. I hope you can read it a little bit. The numbers are small, but as I said, hands out are available, so it will be possible to read all that with your colleagues in your companies. The overall cost savings can be substantial. And the table we have here is based on numbers of end of 2013, December 2013. We tried to put together all the numbers we got from the countries we mentioned here, be it in natural gas prices, be it in electricity prices for industrial consumers. And then, of course, the sales price for structural steel, which is also very subject to a very high fluctuation. But what you can see very nicely, these are the details, which doesn't give you, let's say, too much of a glance at one glance. On the next page, you can really see that there's almost no case where it is not worth at least talking about this alternative. I mean, there are situations with high electricity prices and low gas prices where it could be at the borderline. But normally, electricity prices and gas prices or oil prices are somewhat linked to each other, and according to what we experienced, it's in any case, it's worthwhile looking into that and just asking ourselves the question, could induction heating be a smart answer to a real case in the case given? Okay, then these were the hard facts with the euros or the dollars or the rupees, and but there is another effect, which is the environmental friendliness of the production. And I'm not really sure about the government in India, but I know that the governments in Germany and in Europe and also other countries, they start picking up more and more on industrial consumers, and I think they figured out that they are nice taxpayers which can pay a lot of extra taxes when CO2 emissions are getting imposed. So at least the states in the most European countries, they found out this is a nice way of making more money. And I would be surprised if governments are not learning from each other quickly. So what we had with the customer, with the reference customer, I'm going to show you in Taiwan, he was exactly driven by that because the Taiwanese government found out that with CO2 emissions, NOx emissions, government can make a lot of money. So the industry was interested in reducing that, of course. And you can see here in these case of our three categories, small, medium, and large size Minimills, you can really save substantially amount of CO2 and NOx emissions. And if we try to put that into another currency, meaning cars, such a typical Minimill can have an average saving of CO2 representing 23,000 cars less, or NOx emissions representing 60,000 cars less. And again, these are average numbers. This is not the small car which is almost giving no emissions, and is not the big Mercedes S-Class with a lot of emissions. It's something like an average car in the middle. And it's quite interesting to see that economical profit and environmental advantageousness is not a contradiction. It's really possible to have a combination of both. Now, we stop the theory and we go into the real case that we were happy to realize some short time ago with the company Tungho in Taiwan. And they have different locations, and this line has been realized in their Taiwan plant. And what we did, I mean, you see the layout is pretty much similar to the general layout I've shown you earlier. You see the supply of SMS Concast with the 6-strand casting machine. You see then here very tiny the induction heating unit by Elotherm, and you see the rolling mill by our Italian colleagues from SMS Meer in Tagento. And yeah, if we look into that, I put together here some technical data for you. We definitively don't have to go through that line by line, especially not concerning the scope of supply of Concast and of Meer. I'm pretty sure my colleague here from Danieli, he has a better understanding of all these technical features than I am as an induction heating guy. But I just want to show you a little bit the numbers of the middle section. So we installed here almost 9 megawatts of installed heating power in a very compact environment. It's a little bit more than 8 meters of length that we needed in this whole setup, and we were able to install almost 9 megawatt of heating power into this relatively short length. The total is 6 induction coils. It's each a pair, so we have 3 times 2 coils as a unit. With that, the customer is able to run a production of about 800,000 tons per year of structural steel, and the final size is varying between 9.5 and 43 millimeters round. The customer confirmed us that he is able to do cost savings by this setup of more than 11 euros per ton. Of course, it depends on what kind of production he's running. And the overall cost saving he was able to realize is about 10 million euros per year. I think this is a number which is substantially big to report it in this kind of frame. And summarizing here the benefits that Tungho Steel got from the solution and their decision, what they actually did. Well, they have a very energy efficient, short heating time for their high productivity. The heating line, the induction heating line is relatively flexible, so that means even when they change sizes, we don't have to change the heating unit. We can adapt the temperature, so that is all quite versatile and flexible for them. The small footprint, I mentioned that already, almost 9 megawatts heating power on 8 meters. And we are definitively independent from a direct supply of gas or oil, which reduces the CO2 footprint on this particular factory. Of course, the electricity has to be generated somewhere, but the generation of the electricity normally is done in a power plant, which is much more efficient in terms of CO2 production and so forth. So again, here the economic benefit with 11 euros per ton, and the carbon footprint reduction in this particular case for Changzhou was 72,000 tons CO2 reduction per year, 410 tons SO2 and 225 tons NOx per year, which was a quite important aspect for that customer, because I said it already, the Taiwanese government has already started to become creative in terms of charging customers or industries for that kind of elevated CO2 footprint. So they had another advantage out of that. Not only ecological, but by that, again, a second economical aspect. Okay, summarizing a little bit the benefits of CMT technology when you have an induction reheating unit integrated. We have both cost advantages and environmental advantages. The cost advantages, they break down between the lower investment costs compared to a combustion furnace, and also lower operating costs. And when we look into the details, why is this? The lower investment cost is because we have a reduced overall plant size. It's very compact. We need less infrastructure for combustion fuels. We have no billet storage which is foreseen, and we have less handling equipment which is needed for the overall setup. The lower operating costs result out of lower primary energy costs, a higher output with lower scale formation, higher output with fewer crop cuts, or in case of short bars, and we have lower handling and logistic costs. Finally, not to forget, the environmental advantages is the improved CO2 footprint and other emissions like NOx or SO2. And I hope you recognize that I try to highlight these advantages and the environmental aspects by the beautiful colors of India. And by that, I come to the end of my presentation, and I thank you very much for your attention here in the Lilai Mumbai. And I'm fully available today and tomorrow for any kind of questions, be it now, or be it in the breaks, or be it later or tonight. Thank you very much for your interest on this induction excursion.